Morning, everyone. Let us continue with the topics we were doing last time. We have started with vectors, and we had completed till here, or till here we have completed, right? So we were going to see vector addition, and before that, I told you that let us see scalar addition. So in scalar addition, we are just going to add the scalar quantity, as you can see. So we are just adding the scalar quantities here, right? And 2 plus 3 equals to 5. That is what kind of addition? That is scalar addition, right? That's not vector addition. We're not adding vectors here. What are vectors? As I told you, vectors are arrows. Vectors are arrows. If you have this vector, if you have this vector, you have to add them. Basically, we have to add arrows. Now you wouldn't have any idea how to add arrows because this was never taught to you, right? It was never there in the syllabus to begin with. Was it there? Was it ever there how to add arrows in your syllabus? No, it was never there, right? So adding arrows was never a part of your syllabus. Got it? Never a part of syllabus. So of course that's an entirely new thing to you, and that's what we are going to learn here. That how can you add arrows? It sounds very weird to add arrows, right? But that is a part of physics where we learn how to add arrows, essentially vector quantities. And to add them, there are certain rules, or may I rather say laws. And those laws are called laws of vector addition, right? Those laws teach you how do you add two vector quantities, right? And that's precisely what we are here to look at. So the heading, vector addition. Then there are some rules how you add vectors, right? I have written those rules down, and it is any two vectors can be added using this law. By if you follow the steps, the following steps, if you follow, you should very well be able to add any two vectors, right? And you have to follow this procedure. Let us go to the procedure. First one is bring any head and any tail of the vector together. So you have to bring what? Read it again. Head and tail you have to bring together. Right now, if you'll see what is together. Right now, tail and tail are together. This is not done. No, I don't want tail and tail. What I want is head and tail. Right? Head and tail. That's what. Any head, that will do. Any head, any tail, but it has to be head and tail. Can't be tail and tail. Right? So bring any head and tail together. Are they together? Are they together here? No, they're not together. So if they're not together, what am I supposed to do if they're not together? I have to perform. What can I perform? I can perform something called parallel shifting. I can perform parallel shifting on any one of the vectors. Perform it on any one of the vectors. It's not that you have to do in this vector, on that vector, anyone, any vector. Because our primary objective is just to bring the head and tail together. We don't really care which vector we are moving. That doesn't matter, right? Right. So let's do that. So this is one of the vectors, right? And this other vector, tail and tail are together. We don't like that, so we will move it. We will move it in such a way that what is together? Now you see what is together. You will see that the head of this vector is with the tail of this vector, and we have achieved our objective. Head and tail must be together. Fine. I hope that part is clear to everybody. Head and tail must be together, right? Let's name them. Right. Let's name them. Call it vector A, call it vector B, right? Then join the remaining head and tail by another vector. So this is the remaining join the remaining head and remaining tail by another vector. So this is the remaining tail and this is the remaining head, and you have to join them together because now these guys are together, right? So who is this? Is the remaining tail and that is the remaining head. So join them together. So let's do that. Let's join them together. Like this, right? We have joined. Next, the head of the third vector, this is the third vector. Head of the third vector will lie on the remaining head. So this is the remaining head and the head will lie here only. And tail should lie on the remaining tail. Tail is on the remaining tail and that is correct. And this is the third vector. This another third vector is called the sum or the resultant of the two vectors. So this is exactly the sum of the two vectors, means I'll call it S vector, or you can say sum vector, right? This is exactly A vector plus B vector. Got it? And resultant or sum is a vector that can be identified by, so this is a sum vector. Everybody got it till here, right? This is the addition of A vector and B vector, right? I hope I am clear on that regard. Now sum or resultant is a vector that can be identified by connecting what? So you will notice here that what we have here is a tail and tail, right? Both tails are here, and interestingly both head are also here, right? So resultant or sum is a vector that can be identified. How it can be identified? It can be identified that it is connecting the head and head with tail and tail. That's what it is doing, right? Tail and tail is connected with head and head, and that vector which does this is called the sum vector or the resultant vector. So I'll repeat again. What is the sum vector or resultant vector of the two vectors? It is nothing but the vector connecting the tail and tail to the head and head, right? Now write all this down. These are very important things. I'll enlarge it, take a good note of it, and then we'll move to the next topic. Here we have to identify which is the sum vector. So you have got three vectors A, B and C. You have to identify which one is the sum vector. And I told you which one is the sum vector. How do you identify sum vector, guys? You have to see head and head. So do we see head and head anywhere? Here we have head and head together. Now do we see any tail and tail together? There is tail and tail, right? Tail and tail we have found out, and we found out head and head. And the vector that connects this is the sum vector. And which is that vector? In this case, P vector is the sum vector. So A vector plus C vector is equal to P vector. Right? Now let us see the same thing here. In this case, head and head is here and tail and tail is here. Right? So which is the sum vector? In this case, C vector is the sum vector. So I can write that A plus B must be equal to C. Right? Take this down. Fine. So let's go ahead. Let's do this. I want to add them again. A vector and B vector. So how do you add A and B vectors? What was the process I told you? You have to join the head and tails together. And right now, what are together, guys? Head and head is together. So this will not. This is not something we want, right? This is not something we want. We have to bring the head and tail together, right? So let's see how do we achieve that head and tail together. Tell me, how can we achieve head and tail together? What we have to perform, guys, to bring the head and tail are not together, right? What is together, guys? Head and head is together. This is not done, right? Nope. This is not how I can add the two vectors. I have to do something else about it. What exactly we have to do? We have to bring the head and tails together, right, guys? Head and tail together. Let's do that. So you'll see here in the rules, you will find, yeah, that by we have to bring the can I select all? Okay. So, yeah, what was I saying? I was saying that we have to bring the head and tail together, right? And bring the head and tail together by performing what, guys? What we have to perform? Parallel shifting, right? Parallel shifting. So see, let's perform parallel shifting, right? So that we can get the head and tail together. For that, let us say this is the vector that we are trying to shift. You know, call that vector A, right? And if you want to shift that, uh, let's do the parallel shifting like this. And once you have done that, this vector has been shifted. You can forget about it. And your A vector has been transported forward. Now you'll see that this tail and this head are together, and my first rule, the primary objective is accomplished, that is to bring the head and the tails together. I brought the head and the tails together, right? Now I can go forward with this. You know, with this I can move forward. Okay, so how do I move forward from here? Head and tails are together. The next step, see, these guys are together. So this is the remaining tail and this is the remaining head. And how do I get the resultant? Simply by joining the remaining tail to the remaining head. Let's do that. There it is. It is very lines are not very good. Yeah, more like it. Why it is so high? Below as well. Yes, it's low enough. Perfect. Okay, so and where do we put the arrow? Arrow is on the remaining head. So here is the arrow, and this is the sum vector, right? So this sum is basically made up of a vector plus b vector. And how you can verify that? You can see that head and head is here, and tail is here, right? So this is the sum vector. Got it? Check it out and draw it properly in your notes so that later on you can refer and understand it well. Now let us see how to add these two vectors, A vector and B vector. We have to add them. So how do we add them? How indeed? We take one of the vector, perform parallel shifting, ensuring that the head and the tail are together, and there you can see they are together, right? And the resultant is obtained by joining the remaining tail to the remaining head, like this. Right? So I've brought the head and the tail together. You see, head and tail are together, and this is tail, and this is head, right? And the resultant is formed by connecting the remaining tail with the remaining head, like this. And this must be the sum vector. It is nothing but A vector plus green vector. Which is the green vector, guys? Green vector is your B vector, right? So sum vector is A vector plus B vector. Let's go ahead. Add these two vectors. What will be the sum? One is A vector, another is minus A vector. What is the sum? A vector plus minus A vector anyway is how much? 0. So that we don't have to do anything here. Very straightforward. Right? Next, quantitative vector addition. So this is A vector and this B vector, and I have to add them again. But this time I have to quantify. It's going to be a quantitative addition. What do you mean by quantitative addition? Here we have to find the values of the resultant. Like A and B is given. What are A and B? A and B are the magnitudes of A vector and B vector, right? So I have to find the resultant in this case. I have to find the resultant in terms of A and B and theta. So that is what we have to do. Find the magnitude of the resultant in terms of A, B, and theta. That is the objective of the problem, as you can see here. Right? That's what we have to accomplish. If we accomplish that, this topic is over. Right? There are a bunch of other things also, but that's the primary aspect of it. Right? How do we do that? Let's see. We have A and B vectors. How we go about it, we'll find out. Okay. So for that, what we'll do is we'll do some parallel shifting first, right? Because this is a B vector. We have to bring it forward because we have to first make sure that head and tails are together. Right now the problem is tail and tail are together, so I have to shift one of the vectors. Now which vector shall I shift? The answer is any vector. I can shift any of the two vectors, right? So which one I'll shift? Let's find that out. I'm planning to shift the b vector, right? So let's shift the b vector. Right? This is not moving. It's moving. Value is not moving. Oh, I'll draw it again. That's a b vector. Now let's move it forward. After actually rotate it a bit. Use a bit of rotation. Oh, it's fine. Now let's move it in such a way that what is together? Head and tails are together. And the resultant is obtained by simply joining the remaining tail to the remaining head, right? Like this. Then below. Okay. Right. And that is the resultant vector. And where is the arrow? At the remaining head. There is the arrow. I will call it the sum vector. The A vector, B vector, and sum vector. Right? We have to find the magnitude of S vector, right? Which is S. We have to find the value of S. So how do we find the value of S? Let's think. How can we do that? For that, I will do some construction like this. Then like this, right? The verticals are not possible to draw, right? Can I draw verticals like this? No, verticals can't be drawn. But horizontals can be drawn apparently. No, horizontals also can't be drawn. It should have been here. Anyway, but if one line is there, I suppose another can be made perpendicular to it. No, still no. Weird. Anyway, so this is the construction done, right? And we have to find the value of s, right? So let's name all these points. Call it A, B, C, and D. And I can write down the relation between them. That is ED square equal to AC square plus DC square, right? So ED means S. So S square is equal to AC square, which is, or how we are writing? By Pythagoras theorem, you know. By Pythagoras theorem, I can write AC square is equal to CD square plus, sorry, not AC square, hypotenuse, no? ED square. AD square is equal to AC square plus DC square. That is by Pythagoras theorem, right? Let's put the values. So what can AD be written as? AD can be written as S square. I mean AD is S. How much is AC? AC is B. Okay, AC is interesting. We have to find AC. Let's find AC. How do we find AC? We need AC and DC, right? Let's settle that first. So you'll see that this is a 90 degree here, right? A perfect 90 degree. And you'll see that this angle is theta. This angle is theta. If that angle is theta, what will be this angle? Parallel lines, right? So this will also be theta only, right? You know, that will be theta only. Now I want to find the value of BC and DC. How do I find BC and DC? So for that, what I can do is I can use trigonometry, and I can write sine theta and cos theta values, right? So what will be sine theta equal to? Which I'll write as S, right? Sine theta in short, I'll write it as S. Sin theta can be written as dc by bd. So from here I get dc equal to bd sin theta. But dc is how much? dc is coming out to bd is how much? Now bd is nothing but b itself. This vector is magnitude is b. So I can write as b, and sin theta is simply s. So I can write dc is equal to bs. Right? And similarly, I can find cos theta also. Like this is sin theta. I can find cos theta also. So what can cos theta be written as? Cos theta is equal to, in which triangle are we doing this? If you notice, we're doing it in um, we're doing it in which triangle? In triangle. Which triangle is this? BD, BDC. In triangle BDC, we have written sin theta, right? And the same triangle, we can write cos theta also. Right? Fine. So there's more to it, which we can't complete it now. We'll complete it tomorrow. I'll just write cos theta. So cos theta will be equal to what? Cos theta will be equal to BC upon BD. So cos theta is equal to BC. What is BC? BC is this. BC is this. BC by BD. And what is BD? BD is this, which is B. So you get BC is equal to BC. Right. So we have got these two relations, which we'll need later on. Let's make a box out of them like this. And we'll use it later on in our derivation. We need it here. We'll do tomorrow. As of now, let me save the files. What's the date today? It's 12th. So it is C2 12th, right? 11th J physics documents. That's right. And what we studied today, we'll keep that here. Delete this. Yeah, from here. We can delete this.